This is how to convert a decimal to a fraction of an inch, or any random fraction. So someday if you ever hit with something like 0.9 inches, now you'll know how to convert that to something on your tape measure. So decimal to fraction of an inch, or any random fraction. I'm going to keep this super short and sweet for anyone that just wants to know this, and then stay tuned afterwards if you want more information on this. Fraction to a decimal is easy. If you have 3/8 of an inch, you just hit 3 divided by 8, and voila, you get 0.375. So to take our decimal and turn that into a fraction, we just have to reverse it, and I'll show how. Let's say you got some fancy digital calipers. They read out to about 1/1000th of an inch from what I've heard. So your calipers say something is 0.924 inches. And for some reason you want to convert that to something on your tape measure. I've seen when you get out to 1/1000th of an inch, that's typically not used in lumber, but something like boring a rifle barrel. Those are always in 1/1000th of an inch. You got 357, 308, and I don't know, whatever other calibers they have out there. Okay, so 0.924 inches is what our caliper says. And for some reason, we need to convert this to something on our tape measure because we're going to cut some lumber, perhaps. Tape measures typically go to 1/16th of an inch for accuracy. I've seen a lot of rulers go to 1/32nd of an inch, but we'll keep it at 1/16th. So what we have here is 0.924 inches. That's what our calipers give us. And then what we do here is you simply choose whatever denominator you want. In this case, our tape measure goes to 1/16th of an inch. So we just say 0.924 inches equals something over 1/16th of an inch. Solve for x, basic algebra, bring the 16 up. 16 times that gives you 14.784. So what you do is you replace x with your 14.784 and you get 14.784 sixteenths of an inch. Then you can simply round that to 15/16ths of an inch because that 0.784 is almost 15. Feel free to philosophize if you're supposed to round up or down. I had a laboratory methods class once and the teacher told us we weren't supposed to round up. If the increments were only, say, 14 and 15, all we knew it was somewhere in the 14 area, so we were supposed to round down to 14 because that was our known accuracy. And I could kind of see that argument because you don't have any increments between 14 and 15. But anyways, feel free to philosophize on that. Okay, so that's it. Bob's your uncle, or as they could also say, Robert's your mother's brother. And that's how you get that answer right there, 14.784 or 15/16ths of an inch. If you want to, I can't imagine ever needing to do this. I said here you can choose your denominator. If you wanted to, you could choose a numerator and then decide what denominator that should go over. By just putting x right there for your denominator. But that's pretty much it. If you want more facts on this or more information, then stay tuned and don't touch that dial. Next up, I'm going to deal with the accuracy, just in case anybody's curious how much they're off, because when you convert this decimal to 1/16th of an inch, you're going to have some error, and I'm going to cover how to measure that error or how to quantify that error in case anybody cares. After I cover the basic stuff on my videos, I often like to do a real deep dive to make it like an encyclopedia. So the information's there if you want to look at it, and if you don't, then that's fine too. All right, so here's the can of worms a viewer kindly opened for me. I'll start with an easy example here. You have your actual reading, say something's 10 miles long, distance A is 10 miles long, distance B is 100 miles long. But then you measure it, and your measurement for this one will actually be, say, 9 miles, or it could be 11 miles. Either way, you're off by 1 mile. And that absolute error will be the same for the 100 miles. You're supposed to measure off 100 miles, but instead you get 99, or you could get 101. Either way, you're off by 1 mile. Your absolute error is 1 mile. So you can describe this two different ways. One way is you take the amount that you're off, which in this case is 1 mile, or you could say it's your actual minus your measured, which will still give you 1 mile. Then you divide that by your actual number, which is the 10 right here. That gives you 0.1, which gives you a 10% error. Notice here also, I forgot to write that, so I'm going to write this here. I wrote kind of small here, but that's actually 1 mile divided by 10 miles, so the miles will cancel. and it'll just be 0.1, which is no units, which means you move your decimal point over 2 places, and that gives you a 10% error. I also did a video on showing the logic on why you move your decimal point back and forth to figure percentages, so you can see that if you want to. Then we can also take distance B here, which is 100 miles. We take how much we're off, which is 1 mile, by 100. That gives us 0.01. Move the decimal point over. That means we have a 1% error. So these are our relative errors, 10% here and 1% here, because it's relative to the total amount. Then the absolute error is 1 mile. And the absolute error will have a unit of mile, because that's how much we're off. But then when you do relative error, it's mile divided by mile, so they cancel. And I'll show some fun logic with that here in a couple of minutes. Okay, so back to this. We have 15/16 of an inch is what we're going to have for our estimate. Our real value is 14.786. Take the actual minus the measured, or vice versa, whatever. If you don't want to end up with a negative, I just do big minus small. So this is our real value. This is what we estimated. Divide that by our real value right here, or our true value, actual value. This divided by this. Notice here, when you subtract an inch from an inch, that'll stay as 1 inch. Right here is an inch. You got inch divided by inch, so the units will cancel. So what we do here is we take 15 minus 14.7, bring over the 16 anyways, 0.21616 times 16 over 14.784. You just invert your fraction when you multiply, and you get this. Notice there are no units here, because if I left that as inch and I left that as inch, we will now have inch times inch, which will give us inches squared, which is the area of something. And we're definitely not dealing with areas of something. So anyways, we have a 0.0146 is our relative error. Move your decimal point over 2. That gives us a 1.5% error as a relative error. Now, this can of worms led me to open another can of worms. Since this is unitless, I thought, I want to do something to give this units. So this is what I got here. We have 0.21616 of an inch. That is how much we're off, or that is our error right here, because I took 15/16 of an inch, which is our estimate, minus our actual right there. You take this over to here, we'll get 0.21616 of an inch. Notice we get to keep our units there. So now we are off by 0.0135 inches. This is our absolute error. I should have written that here. Absolute right here, and I'll call that relative right here. There. So with our absolute error, we get to keep our units, kind of like when I showed that example with 1/10 of a mile or 1/100th of a mile. For our absolute error, we keep our units. Also remember, I'm not an expert. I just figure this stuff out and make a video, so feel free to chime in if you see any problems with the terminology or whatnot. Okay, so anyways, we got 1.4% of an inch. So you got your whole inch right here, about that yay long or so. 1.4% of that is how much we are off. You could also say it's approximately 1/100th or 1% of an inch off, or 1/100th of an inch error. And so again, we keep our units. I'm going to cover another example now to show that as you increase your denominator, so instead of going to a 16th of an inch, if you want to go to a 32nd of an inch or 64th of an inch, your error rate will get smaller and smaller. So that's what I'm going to do on the next pages. Right here, we have the imperial system. The way the imperial system works with tape measures and rulers and whatnot, it just keeps, you take your increment and you just keep cutting that increment in half. So it goes 1/2, 1/4, 1/8, yada, yada, on up to 128th of an inch, for example. I wonder, I don't have any digital calipers. I wonder if a digital caliper could give some sort of fancy fraction like that, or if they just always stick to decimals. But you're not going to see anything with this kind of accuracy on a ruler or a tape measure, because the ink lines would be too large. We just set up the problem the same way here, 0.924 inches. I use the same number from the last example, equals x over 128. 128 times 0.924 inches to isolate our x. X will equal 118.272. And what that means is 118.272 over 128 of an inch. And then we can round that down to 118 over 128 of an inch. They're both even, so we can reduce that to 59/64 of an inch. Now that is our absolute measurement, or that is our measurement on what we're going to use for our working, like when we cut the board or whatever, or when we machine down that part, whatever. But now I'm going to calculate the error rate right here by doing the same thing. I take the actual minus the measured, divide it by the actual right here, and I will get inch divided by inch, so they cancel, which means no units. When you divide by complex fractions, you bring up the bottom fraction and invert it, so it looks like this: 0.272/128 times 128 times 128 over 118.272. Go through the math, you get 0.0022998, and I believe that decimal goes on if I remember correctly. Again, I just wrote here, notice it's not in inches squared because we did not multiply an inch by an inch. And we can interpret this as moving our decimal point over, say, 3 places, tenths, hundreds, thousands. We're going to get approximately 2 1,000ths, or 0.2% of a error. And this is our relative error, so we don't have any units. So now if we want to see how much of an inch we're off by, like are we off by a 1/4 inch or a 1,000th of an inch or whatever, and we want to keep our inch units, then we can take how much we're off. We're off by 0.272 128ths of an inch. So obviously that's a very small fraction of an inch. Go ahead and divide 0.272 by 128. We get 0.0021 inches is how much we're off for our absolute error. We can move our decimal point over 2 places to get 0.2% of an inch. Or we can also say that's tenths, hundreds, thousandths. That's 2 1,000ths of an inch error. Make that a little bit darker there for that inch. We're keeping our units here. And that'll reduce 2 1,000ths will reduce to 1/500th of an inch error. And that is our absolute error. So if we have an inch and we divide it up into 500 units, then we'll be off by approximately 1 out of those 500 units.